Hello everyone, how are you all? Today our video is about application of logarithm. How we can apply the properties I have told you in the previous video. So if you will try in the questions, the properties will be very easy for you. So the first question is log of 256 divided by log of 16 is equal to log of x, and we have to find the value of x. Find x. See, we know the property log of m by n is equal to log m minus log n, but here it is log of 256 divided by log of, that is, it is like log of m divided by log of n. So these are different things. Log of m by n we can write it like this, but log of m divided by log of n is not equal to log of m minus log of n, and this is the common mistake that is done by most of the students. So you have to be careful that log of m by n equals to log of m minus log of n, but log of m by log of m is never equal to log of m minus log of n. So this mistake you should not commit. That's why I have given this property, otherwise no use of this property here. And one more thing I have already told you, that log of 256, here there is no base. So whenever base is not mentioned, it is already that we have to take log of 256 to the base 10. So wherever base is not mentioned, it is already clear that base is always 10. Now 256, we are having this log of 256 log of 16 is equal to log of x, and we have to find the value of x. Now 256, can we write it like 16 square? We know that 256 is 16 square. Divide by log of 16 is equal to log of x. Now we know one more property, log of m square, means whatever is the value in the power, that will come out equals to 2 log of m. So here is the same case, log of 16 square, so 2 will come out 2 log of 16 divided by log of 16 is equal to log of x. Now 2 log of 16 divided by log of 16, log 16 log 16 cancel out. So we are left with log of x is equal to 2. In the left hand side we are having only 2, so log of x is equal to 2, but base is not mentioned. Now how we can find the value? We have to convert it in the exponential form, and base is not mentioned, so we can write log of x to the base 10 is equal to 2, and now we are having base, we will convert it in the exponential form, and this base will go to the that side, that is 10 square. It becomes, there is a rule I have already, these all things you can see in my previous video. There is a basic video on exponential and logarithmic functions, and you can see each and everything very clearly. So x is equal to 10 square, and 10 square is equal to 100. So this is our first question, but the main thing in this question is that log of m by n is equal to log m minus log n, but log of m by log of n is never equal to log of m minus log of n. So we can't use that property here. We have to convert it in the same, and ultimately we have to convert it in the exponential form, and we got the value of x, that is x is equal to 100 here. Now see the second question. We have to find the value of log of 4 to the base 3 into log of 5 to the base 4 into log of 6 to the base 5 into log of 7 to the base 6 into log of 8 to the base 7 into log of 9 to the base 8. See, we have to find the value of this log of 4 all this. Now we have learnt one formula, log of b to the base a equals to, this is also called change of base formula. The log of b, whatever is this number, it will come in the numerator, and whatever is our base, it will come in the denominator. Log of b by log of a, and we will introduce a new base. Here base is a, this base will come here, and we will introduce a new base. Suppose I am taking base m, and if I am not taking any base, that is understood that I am taking base 10, so no need to write. If our requirement is not like that, so no need to introduce a new base, we can just take it as it is. So in this question I feel I don't feel the requirement, so I am taking it as it is. Now according to this, log of 4 to the base 3, how I can write it? Log of 4 divided by log of 3 into, by using this formula. This is also called change of base formula. Log of 5, whatever number is here, I am writing in the numerator, and whatever is the base, it will come in the denominator. So log of 6 divided by log of 5, log of 7 divided by log of 6, log of 8 divided by log of 7, log of 9 divided by log of 8. So each and every number, by using the change of base formula, we have converted like this. This is log of 9 to the base 8, we have written log of 9 divided by log of 8. So many things gets cancelled. See how many things we can cancel. Log of 4 with log of 4, log of 5, log of 5, log of 6. It is very interesting to cancel the things, I always like. So we are left with log of 9 divided by log of 3. Log of 9 divided by log of 3. How we can solve it? We can write this 9 as 3 square divided by log of 3. Afterwards I am writing here log of 3 square divided by this, and here I will use the formula log of m raised to power n is equal to n log m. Whatever is the power, it will come here, n log m. Same thing is here, 2 log 3 divided by log 3. Now log 3 we can cancel, we are left with 2. So see, the answer of this whole thing is just 2. How the log in log, how the questions we can solve, and it becomes very easy by taking the help of the properties. In the previous video only I have told you all the properties, and here is the application of all the properties, how we can apply in the questions. So once again I am telling log of 4 base 3, all the numbers are here and we have to multiply all these numbers. So by using the change of base formula, log of b to the base a is equal to, I can write log of b divided by log of a. So log of 4 to the base 3, log of 4 divided by log of 3, same last log of 9 divided by log of 8. So whatever we can cancel it. We are left with log of 9 divided by log of 3, and log of 9 we can write it 3 square. So divided by log of 3, and by using the property log of m raised to power n is equal to n log m, we are using the same property here. This 2 will come in front, 2 log 3 divided by log 3, log 3 cancel out, and we are left with 2, and that is the answer of this total product. Now see the next question. Log of 5 to the base 10 plus log of 5x plus 1 to the base 10 is equal to log of x plus 5 to the base 10 plus 1. By seeing it, it seems typical that we can solve this, but what will we do with this 1? So first step, we know that log of a to the base a, whenever this number and base are same, the value of the log becomes 1, and one more property, log of m to the base a plus log of n to the base a is equal to log of mn to the base a. If the two numbers are in addition, when we have combined, then mn will become. So these two properties we will use. We can write our given equation. This is m and this is whole n. So we can write it 5x plus 1 to the base 10. Here one thing you have to notice, that base should equal. Here in both the things, base is 10 is equal to log of x plus 5 to the base 10 plus. Now the interesting thing about this 1 is that we can write this 1 as log of 10 to the base 10, because everywhere we are taking base 10, therefore here also we will use base 10, and whenever base and this number are same, its value is 1. I have written this property, so I can write this 1 as log of 10 to the base 10. Now question become very easy. And we can write this part also by using this property, log of m plus log of n is equal to log of mn, that is 10 into x plus 5, and here it becomes log of 25x plus 5 to the base 10 to the base 10. Now the two things are equal, they are having the same base and having the same log, so we can equate them. 25x plus 5 equals to 10x plus 50. We are multiplying them, 10x plus 50. Now 25x minus 10x is equal to 45. 50 minus 5, 45, and it becomes 15x is equal to 45 and x is equal to 3. So our aim was to find the value of x. Here it was given and our question was find x. So we have found the value of x, that is x is equal to 3. And one more time I am explaining, log of 5 base 10 plus this is equal to this plus this. Now these two things we were knowing, this this one was little problematic. So what we did with this one, we write it with the same base, and because everywhere base was 10, we consider it log of 10 to the base 10. If everywhere base might be 20, you can write it like log of 20 to the base 20. So this property we are using, the sum of them converts in product. So here log of 5 into 5x plus 1 is equal to log of this plus this one, I have written log of 10 to the base 10, and here again mn property I am using the product property, log of 10 into x plus 5. Again we are just equating them because they are having the same base, and we are taking the log of these two numbers. Therefore by equating and solving, we got the value of x is equal to 3. Now our fourth question is log of m to the base 8 plus log of 1 by 6 to the base 8 is equal to 2 by 3. We have to find the value of m. Here again we will use the property of product. We know that log of m plus log of n to any base a is equal to log of mn to the base a. So By using the same property, I can write it like log of 1 by 6m to the base 8 is equal to 2 by 3. Just I am using this property and I have written this. Now what we can do? We can convert it in the exponential form so that we can find the value of m. And what is that? We know that log of b to the base a is equal to m. This implies a raised to power m. This a shifts here just. Here a is the base, here also you have to take the base a raised to power m, and whatever is the power, it becomes the answer. So a raised to power m is equal to b. So here 8, when it will shift here, it will become 8 raised to power 2 by 3. This you have to be taken very carefully. 8 raised to power 2 by 3 is equal to 1 by 6 m. Now this 8 we can write it 2 raised to power 3. We know that 8 is equal to 2 into 2 into 2, that is 2 raised to power 3, and this 2 by 3 is outside already, and by using the exponent properties we can multiply them. 1 by 6m, this 3 gets cancelled with this 3, we are left with 2 raised to power 2 is equal to 1 by 6 m. 2 raised to power 2 is equal to 4, 4 is equal to 1 by 6 m. This implies m is equal to 4 into 6, that is 24. And what was our aim? We need to find the value of m. So only property we are using of the addition property, and it converts in multiplication. After using that property, we have to convert our given logarithmic function in the exponential function so that we can find the value of m in a very easy manner. Just by converting it in exponential form, we are using the properties of exponents that I have already told you. So 2 raised to power 2. 2 square is 4, 1 by 6m, this implies m is equal to 24. So we have found the value of m. Now see the next question, question number 5. ln 2 log 625 to the base b is equal to log of 16 to the base 10 ln 10. Find b. We have to find the value of this b. See, here it is given that ln 2. So what is ln? We know that it is natural log. ln means natural log, and whenever natural log, this means its base is always e. Natural log, we can write it log of 2 to the base e, and log of 625 we can write it as 5 raised to power 4 to the base b. Okay. Write it as it is. 625 to the base b is equal to log of 16 to the base 10, and again ln 10. We can write it log of 10 to the base e. So first of all we have to convert ln to the simple log, and what it mean? It mean that base is always e. Now see, somewhere it is base is e, and sometimes it is 10 and sometimes it is b. So how we can solve it? It will be difficult, no? So first of all, we will, by using the change of base formula, we will try to make our base same. And what is change of base formula? Log of b to the base a is equal to log of b divided by log of a, and base we can take anything. Suppose here I am taking 10. We can choose any base, 8, 10, 20, whatever, e also. Now here log of 2 to the base e, I will write log of 2 divided by log of e, and base what I will choose? I will choose the base 10 to make it same, because somewhere it is 10, somewhere it is e, it will create problem. So I am converting each term to the base 10. This term, by using the change of base formula, I can write it log of 625 divided by log of b. Again I am giving them base 10 equals to log of 16 divided by log of 10. Oh sorry, no need to convert here, because log of 16 to the base 10 is already in the form of base 10. So no need to convert, and if we will convert, we will get the same value. So we can write log of 16 to the base 10, and this thing we will convert log of 10 divided by log of e to the base 10. For both numbers, log of 10 divided by log of e to the base 10. Now both the terms are in equality, so we can cancel this log of e to the base 10, log of e to the base 10. Very easily we can cancel them. Anything we can cancel? No. But we know that log of 10 to the base 10 equal to 1, because we know that log of a to the base a is always 1. Whenever this number and this base is same, we got the value 1. Now how we can solve further things? Log of 2 to the base 10 into this number 625, we can write it as 5 raised to power 4. Log of 625, log of 5 raised to power 4 to the base 10 is equal to, and this 16 we can write 2 raised to power 4 to the base 10, and this log of 10 to the base 10 equal to 1. So next step is log of 2 to the base 10 into, now this 5 raised to power 4, in all the questions I am telling, now I am using the direct property log of m raised to power n comes out, it becomes 4 log of 5 to the base 10 equals to, this 4 comes out in this case, log of 2 to the base 10, and this 1 multiplied with this number, so we are left with only this number. This 4 gets cancelled with this 4, and this log of 2 to the base 10, log of 2 to the base 10, these things also we can cancel. So in the right hand side we are left with only 1, that is log of 5 to the base 10 equals to 1. One mistake we have committed, this was also there, log of b to the base 10, this we need to write. In this step also we need to write log of b to the base 10. So in this step we forgot to write, so I am writing here log of b to the base 10, this 4 cancels with this and this cancels with this. We are left with log of 5 to the base 10 and this log of b to the base 10, and when it will go to the right hand side, it will multiply with 1 and it will become log of b to the base 10. Now log of 5 to the base 10 equal to log of b to the base 10. We can equate them very easily and they are having the same base, so there is no problem at all. We can directly say that b is equal to 5 here. Just by equating, we can equate whenever their bases are same and we are taking the log of two numbers. We got b is equal to 5. This was little typical question because new term we used ln. What is ln here? It is natural log, and whenever we are talking about natural log, we are talking about a number whose base is always e. So that I wrote it in the form of log of 2 to the base e, log of 625 to the base b is equal to this thing. Here ln, again I am writing log of 10 to the base e. and we know the change of base formula. We can take any base 10, and here we are taking base 10 because somewhere it is e, somewhere it is 10, and whenever we are taking base 10, things becomes more easy. So we are converting all the numbers to the base 10. It becomes log of 2 to the base 10 divided by log of e to the base 10 into this. Everything I am writing just by using the change of base formula. Now this and this thing we can cancel out because they are same and in the denominator. Remaining things I am writing as it is, and log of b to the base 10 is as it is in the denominator. Now log of 2 to the base 10 into 4, I have written this 4 we can cancel, and one more thing, this log of 10 to the base 10 is 1. So in place of this we are writing 1 is equal to 4 into this. 4 cancels with this, and this log of 2 to the base 10 gets cancels with this. We are left with log of 5 to the base 10 divided by this equal to 1, and whenever this comes to the right hand side it becomes this. We got the value b is equal to 5. That is the final answer, and this was our question that we need to find the value of b, and we got it, that is b is equal to 5 here. Now next question is 1 by log of ABC to the base a plus 1 by log of ABC to the base b plus 1 by log of ABC to the base c. We need to prove that 1 by this, 1 by this, 1 by this equals to 1. So see carefully, the property which will be used in this question will be log of b to the base a is equal to 1 by log of a to the base b. This is also called change of base formula, and here this number and base are reciprocal of each other. If we are taking this base to the place of b and b in the place of a, they become the reciprocal of each other. So log of b to the base a equals to 1 by log of a to the base b, means they are reciprocal to each other. Same is the case. Now see here carefully, 1 by log of abc to the base a. If I am changing this base up to this number, so reciprocal whenever we will take, it will become log of a to the base ABC, the product of three numbers. Don't worry about that how we can take the base as the product of the three numbers. It can be anything, because after solving it, it will always give us a simple number, so there is no problem at all. Now we have taken the reciprocal by changing its base, so it becomes log of a to the base ABC. Similarly, this it will become log of b to the base ABC, plus it will become log of c to the base ABC. So we are having our left hand side, we are considering only left hand side equals to this. Now we will use the property. If we are having the same base and we are adding three numbers, log of a, log of m, so what it will become? Log of m n o to the base a, but the condition is base should be same. So we can use this property for 2 numbers, 3 numbers, 4 numbers, and so many numbers. There is no problem at all. Just one condition, that base should be same and numbers should be added. Then after combining them, they become in the product. Log of m n o up to the base a. Same is the thing here. This is the property we are using. So what it will become here? Base is same, ABC, ABC, ABC. Now log of ABC, we need to take the product of these three numbers, ABC, and here also ABC. So it becomes log of ABC to the base ABC, and we know that if we are having two numbers, with the same base, log of a to the base a, it is always equal to 1. So what it will give us here, this number and base are same, therefore log of abc to the base abc equal to 1, and this we need to prove. This is our right hand side, therefore left hand side equals to right hand side, hence proved. We have proved by seeing it, it was looking little difficult, but by using all the properties, we should know all the properties very well, and for this you should see my previous video on logarithmic, and all the properties will be very easy to you. Now we will take the next question. Log of x plus 3 plus log of x minus 3 equals to log of 27. See here, it is again what it is, log of m plus log of n, and we know that it gives us log of mn. Here base is not mentioned, so we can take any base, but if we need, we should consider the base. If base is not mentioned, we know the base is 10, that is common log, but if we feel that we need the base, we will take. If we feel we don't have any requirement, we will not consider. So it is pretty cool question. Just what you have to multiply these two numbers, log of x plus 3, x minus 3, it is equals to log of 27, and this is log of x square minus 9, a plus b, a minus b, a square minus b square, that is x square minus 3 square, 9 is equal to log of 27. So log of x square minus 9 is equal to log of 27. There are two numbers, they are having same base, base is not mentioned, therefore they are having the same base. So number we can equate very easily, no problem. So x square minus 9 is equal to 27, x square is equal to 27 plus 9, that is 36. So we are getting two values of x. X is equal to plus minus 6. This question I am taking only because to tell you that only positive values we can consider. If suppose I am taking x is equal to minus 6, then what it will become here, log of minus 6 plus 3, that is log of minus 3, and that is not possible at all. In the starting only I have told you that if we are having log of b to the base a, there is a condition that b should always greater than 0. B can't be negative. So log can't take negative value inside it. X is equal to minus 6 is not possible because log can't take negative values inside it. Log can't take negative values inside it, therefore x is not equal to minus 6. Only possible value of x, that is 6. So x is equal to 6, and this was our question. We have to find x because there is only one unknown, that is x, and we found that unknown very easily just by using the property of addition. Now next question is, if x, y, z are the sides of a right angled triangle and z is the hypotenuse. Z hypotenuse, that is the longest side. We need to find the value of 1 by log of y to the base z plus x plus 1 by log of y to the base z minus x. We need to see x, y, z are the sides of a right angle triangle. We have a right angle triangle and its sides are mentioned x, y, z, and z is the hypotenuse. Longest side is hypotenuse. See, this is a right angle triangle. Here it is mentioned that z is the hypotenuse. Other two sides can be x, y. There is no problem. It can be x, it can be y. So third side is automatically given. This is the right angle triangle and z is the hypotenuse. Because z is the hypotenuse and it is a right angle triangle, therefore by Pythagoras theorem, we know that z square is equal to x square plus y square. Everyone knows the Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square, therefore z square is equal to x square plus y square. Now we come to our question. Our question is, we have to find a value of 1 by log of y to the base z plus x plus 1 by log of y to the base z minus x. Very interesting question. Just we have to change the base, that is log of b to the base a is equal to 1 by log of a to the base b. These two numbers are reciprocal of each other. Same thing. First of all, we have to make the we will convert log of z plus x to the base y plus log of z minus x to the base y. So it becomes log of z plus x to the base y plus log of z minus x to the base y. We have made the base same. Here y, y. Here bases were not same, z plus x, z minus x, but by taking their reciprocal, we have made the base same. Now we can put these numbers in bracket because it is a single number. Now property log of m plus log of n is equal to log of mn, because bases are same. Therefore log of z plus x into z minus x to the base y is equal to, now it becomes a plus b, a minus b, and we know that it is a square minus b square log of z square minus x square to the base y. Now from here we will use this, z square is equal to this, z square minus x square, what it will be, equal to y square. So from here, by using that z square minus x square, we can write it equal to y square to the base y. Again this thing, it is, now I am using the property log of m raised to power n is equal to n. N comes out, this 2 will come out, it will become 2 log of y to the base y, and we know that log of a to the base a equals to 1. Therefore 2 into 1, that is 2. So 2 log of y to the base y, it is equal to 1. 2 into 1 is equal to 2. So the value of this much big thing is so small, only 2. This was the question, and this is the beauty of logarithmic, how it can convert the big functions into small numbers. Now see the next question. Log of y to the base 5 minus log of root y to the base 5 is equal to 2 log 5 to the base y. Find y. We have to find the value of y. So simply using the properties we can solve this question. Because it is log of m minus log of n is equal to log of m by n if they are having the same basis. Suppose we are having the base a. So we know this from left to right, right to left. Both ways we can use this property. So it is given that log of m minus log n, log of m by n. So we can write our given number as log of y divided by root y to the base 5 is equal to, but see, everywhere base is 5 and here base is not 5, it is y. So we will convert it by 2 of log of y to the base 5 by using log of a to the base b is equal to 1 by log of b to the base a. Just by taking the reciprocal we can change the base. So I have changed the base here because everywhere it was 5. I have made this also 5. 2 divided by log of y to the base 5. Now we will solve it. It is y raised to power 1 and it is y raised to power half. So after solving it we will get y raised to power half to the base 5 is equal to, by using the laws of exponents we know that any number a raised to power m divided by a raised to power n is always a raised to power m minus n. By using this law I have done this y raised to power 1 and here root y means what? Root y means y raised to power half. So y raised to power 1 minus half, by using this law we are getting y raised to power half is equal to 2 divided by log of y to the base 5. Now this number will come out by the property we have used so many times. Now you know this property, half will come out. Half of log of y to the base 5 is equal to 2 divided by log of y to the base 5. Now cross multiply. This 2 is with the whole. So cross multiplying we got log of y to the base 5 is equal to 2 2s are 4. Log of y to the base 5 is equal to 4. Now we will convert it in the exponential form. We will get this 5 will shift to here. Sorry, this log of y to the base 5 whole square. We will get log of y to the base 5 whole square because this and this. Whenever we are doing cross multiply, we will get whole square equal to 4. So log of y to the base 5 is equal to plus minus 2. Whenever this square go to that side, it will become under root of 4. It will give us two values plus minus 2. From here we can say y is equal to 5 square or 5 raised to power minus 2 because it is giving us two values, and when it will shift here, when we will convert it in exponential form, we will get y is equal to 5 square or 5 raised to power minus 2. From here we got y is equal to 25 or 1 by 25. Here we can see that both the values are valid. Values can be in reciprocal, they should not be in negative because on negative values log is not defined, but here we got two values, y is equal to 25 or y is equal to 1 by 25, and both the values are absolutely fine. There is no problem in this. So we have to find the value of y, and ultimately we found two values of 5 and both the values are correct. So after using properties, we are very used to how we can use the properties, and questions are very easy. Now next question is log of 2 to the base 2 plus log of 2 square to the base 2 plus log of 2 cube to the base 2 plus log of 2 raised to power n to the base 2. This is the question. We have to find the value of this. So first of all, log of 2 to the base 2, and here 2 raised to power 2. So 2 will come out by using the property log of a raised to power m is equal to m log a. Power will come out. So here power is 2, it will come out. It will become 2 log of 2 to the base 2 plus 3 will come out, log of 2 to the base 2 up to n plus n will come out, log of 2 to the base 2. Now see, we got this, but we know that log of a to the base a is 1, and here log of 2 to the base 2 is 1 plus 2. This is 1, 2 into 1 is this, plus 3 plus n. So what we need to find? We need to find the sum of first n natural numbers, and we know that the sum of first n natural numbers is n plus 1 divided by 2. Everyone knows, and if you are not knowing, you can find it by using the AP, because this is a sequence, and see this sequence is in AP. AP means arithmetic progression, and here common difference is same. Common difference is 1 here. Here a is the first term, a is equal to 1 and d is equal to 1, and we know that sum of first terms is equal to n by 2 a plus l. Here a is the first term and l is the last term. So n by 2, what is our first term? 1. And what is our last term? That is n. So it becomes n plus 1 divided by 2. If you are not knowing how we wrote this, the sum of first n natural numbers, you can directly use it. If you have any problem, by using the concept of AP, AP means arithmetic progression. Here a is equal to 1, d is equal to 1, and sum of first n numbers, the formula is n by 2 a plus l. If you have any doubt about AP also, AP means arithmetic progression, you please tell me in the comment. I will make a separate video to make you understand the concept of arithmetic progression in a very simple manner. So I hope you understood how we apply all the properties of log in the questions, and the question becomes very easy, and how it converts the so big numbers in very simple form. I hope you like today's video. If you have any problem, please ask me in the comment section. I will definitely answer. So see you in the next video. Till then, bye bye.